Everyone, me, Ali, and Yazan are going to demonstrate the CFD project that we did on COMSOL. First, we are going to start by using the model wizard. Then we are going to choose 3D because our model is a sphere. Then we are going to choose laminar flow and steady state instead of turbulent or time dependent, since we want to avoid any complications. Then we are going to introduce our structures, starting off with a sphere. We are then going to insert the needed dimensions for the sphere in millimeters and the position of the sphere in the 3D axis. Then we are going to insert the block, which is going to be the airflow domain, and we are going also to choose the dimensions and the position of the block, which is going to contain our sphere. Now we are going to choose the materials for our structures. First, we are going to choose the material for our domain, which is going to contain the fluid. In this case, our fluid is air. Then we are going to introduce also the material for the sphere, which is going to be iron. That's done. We are going to choose the structure that is involved in the different materials. Here is the block, and here it is the sphere. Okay. Now we are going to introduce our fluid properties and boundary conditions. Here we are choosing the domain as the block. We removed the sphere from the domain. Then we are going to choose our inlet value, which is going to be a velocity of 1 meter per second. This is the inlet boundary condition. And now we are going to choose our outlet boundary conditions, which is going to be zero gauge pressure, which is atmospheric pressure. Here we are going to specify which is our inlet, which side is our inlet, or which face is our inlet. And then we are going to apply symmetry to the sides of the block or our domain to avoid any extra calculations, since we assumed that our results or our calculations are symmetrical on all sides of the block. We also assume no slip conditions for the walls of the block and the walls of the sphere.
Now for the mesh, we chose the free tetrahedral for both the sphere and the air block diagram, or the air block that contains the sphere. And for the sphere, we chose, or first of all, for the air block, we chose fluid dynamics, and we added a coarse mesh. And then we add another free tetrahedral for the sphere. For the sphere, it would be a finer mesh than finer mesh quality, as to improve the yielded results. This was a compromise between the computational time and the accuracy of results that is to be discussed in the report. Sphere follows is calibrated for general physics, unlike the air block, which was for fluid dynamics. And then we build the mesh, which can be seen here, which was deemed up to standard for our project.
So now we're gonna talk about compute our results. So as you can see, I'm gonna skip forward through the video a bit, so that okay. So here we get it's gonna give us all the results. Yes, so we got the results here. As you can see, we have the velocity magnitude in meters per second. I make it more clear by decreasing the number of planes and taking the interactive button. I'm going to show a side view will be shown right now of the velocity magnitude. Here we can see the red line are the maximum values, and as they get bluer, that means they decrease. And here we show the pressure values on the sphere. As you can see, at the point where the flow hits the sphere is where the maximum pressure is, and as it goes around the sphere, the pressure decreases. Now we're gonna show a detailed view of the mesh. We're gonna show a plot of a clear plot of the mesh. Here I rotate it. As you can see, this is how the mesh turned out, a bit more clear. This shows the mesh of the outer, where the rectangle is, where the air is. Here we try to get a cross section of the mesh, so we can show the sphere. As you can see, this is a cross section as where the mesh starts, where the mesh, it's kind of in the middle of the sphere. And here, by this we end the video for our procedure for the mesh and for the project. Thank you for watching, and yes.